Welcome to this BiofilmQ tutorial. My name is Hannah and today we will have a look at the 2D XY plot per frame. In the previous tutorial we have already had a look at the visualization tab in general and we have learned how to load your data in there. So now I have loaded some example data which contains 59 files as well as 2 channels. It's very similar to the data the sample data that we have provided online, only that it contains a few more time points. So now if we want to look at the 2D XY plot per frame, we can do this either with the single object parameters or the global biofilm parameters. And we'll start with the global biofilm parameters here. Global biofilm parameters means that for each of the files, there is only one value which was calculated, because the value is calculated for the whole biofilm. You can see here that we have different types of parameters. We have some where they just have a name and others that have a little plus next to them. And if we click on that plus, you can see the list extending. And now we have a couple of parameters that all start with the same name. This is because this particular parameter, intensity mean channel 1, exists in the single object parameters. And what we see in the global representation are averages or maximal and minimal values for that. So here, for example, this value represents the maximal value of all cubes of intensity mean channel 1. We can also look at the mean value, where we have calculated the mean averaged weighted by biomass, the median, the minimal value, the 25 percentile, 75 percentile, as well as the standard deviation of the intensity over all of the cubes of the biofilm and the standard deviation weighted by biomass. So this is again only one value per file, but it contains information about the local properties. So if you want to plot these global biofilm parameters, let's start with something simple. Let's plot time on the x-axis and the cell number on the y-axis. Here we have chosen the specific plot type 2D XY plot per frame that we want to talk about today. And now if I click on plot, you can see a plot is generated where we can see the number of cells over time. We can see the increase. We could choose a different plotting method, for example, a line or bars, and it would look different depending on what we want to show. Of course, I can also show a different property. For example, I can look at the volume of the cells, the maximal volume, for example, over time. And again, I can have a look, or maybe a scatter plot is better here. I can have a look and interpret this data. And in this case, for example, I can see that the maximal volume of all the cubes increases over time, which means that at some point here, there's at least one cube which is always filled to the fullest, which means that the whole cube is filled with cells. So this also makes sense. Now, if you want to plot single object parameters with this method, you can see this field turns red because it no longer exists in this data set, so we'll have to choose something different. We can plot again something over time, for example, the distance from substrate. And here now we have, for the distance from substrate, we have one value for each of the cubes. However, if we want to plot them over time in a 2D plot, we need to somehow get them into one number. And this is the method here. So this would mean in this case, I would calculate the mean distance from substrate over all cubes normalized by the object biomass. And I can also plot the standard deviation with it. There are other methods that I can use here. I can use the mean, which is not normalized by the object biomass, the median, as well as the quartiles, but I can also look at the sum or the minimal and maximal value. So this enables me to also calculate properties. They will be very similar to if I had used the global biofilm property right away, However, for example, here I would be able to apply a filtering option before the mean is calculated. So let's look at the mean distance from substrate and also plot error bars. And you can see here it increases over time, which makes sense because our biofilm grows in the third dimension. And you can also see that there is a very large standard deviation, which means that some of the cubes are there is a great variation of the distance to the substrate between the cubes, which makes sense because there will always be cells which are very close to the substrate and cells which are very far. So in this case, actually, the error bars don't give us much information. However, maybe if we choose a different parameter, for example, the mean intensity, we might gain information from the error bars because they would tell us how much does the intensity fluctuate over time. So here we can see, interestingly, that the fluorescence goes down at first and then increases. And we can also see that there is quite some variation between the fluorescence between different cells. So now we have seen how to use this plot option 2D plot per frame according to method. In additional tutorials, we'll talk about the other plot options.